So in this video, I wanted to go over the geoprocessing tools clip and intersect. The reason they're combined in this single video is I want to go ahead and compare the two. So when you are faced with a choice, do I want to use clip or intersect? We'll compare them directly with this video. You can see here on our mock-up map that we have added two buffers. Will help with comparison between clip and intersect. A couple of the pitfalls I want to point out with with intersect specifically. It's something to be aware of. It's not necessarily a huge problem. But anyway, just like with our buffer video, previous videos, we want to hop to analysis up here, and we want to go ahead and grab tools, and we have our geoprocessing. Again, you may see it start out with a favorite list, and as before, we have our quick links. Again, I want to encourage and disabuse people of using this quick links section and stick to tools and the geoprocessing tab in toolbox. So the two tools, again, we're talking about today are clip here, and let me hop back and intersect. All right. The operations they perform are very, very similar. All right, but we want to go ahead and just go ahead and run them and see what happens. So with clip, the general concept, again, if you're unsure, you can always float over the question mark when we've got tool to cut out a piece of one feature class using one or more of the feature classes in another feature class. What does that translate to? Essentially, we can take our blue buffer here and say clip out the area for our grassland here. And in a series of operations, we could go ahead and cut the area for the rivers, our chemical spill area, and the points as well. One thing to keep in mind is how the output files attribute table is constructed. All right, and what I mean by that, you'll see when we take a look at a comparison between a clip outcome and a intersect outcome. So let's go ahead and just run it. The question I'm going to pose is, let's use this blue as our quote-unquote study area. All right, and we don't care about the rest of the stuff around here. We just want to cut the chemical spill and our grasslands. All right, and cut it down. So again, we can check our information, the features to be clipped and clip features, the features to use to clip the other feature. These aren't super helpful. All right, what I would suggest is the clip features is the operation, the cookie cutter. All right, so our big buffer, which I'm going to clip and drag over, and we'll start out with grassland. Let's see here. All right, and output feature class again. For you, we want to make sure this is going to S drive. I'm just going to leave it, but please, I stress this, I can't stress it enough, move your files. All right, so let's go ahead and run the clip. So if we were to turn off grassland, all right, we have just the common area. So you see here grassland clip. All right, and then what has been cut out of it. All right. What other things can we see and observe? Let's turn grassland clip off. All right. We can turn off chemical spill. All right. It is just the grassland that has been clipped. All right. This is the section that is underlying the study area. All right, but it's set to transparent, so the colors are a little different. I just want to be clear about that. So if you were to want to, let's say we wanted to clip out everything. Let's switch in points, and we want to say grassland clip points, and run. All right, let me turn off all points. So now we're getting down. Let's see, grassland clip. Let me turn that on. And let me switch chemical spill. And we say grassland clip, spill. And one thing you may notice is I'm leaving this tool open and I'm just switching out the data sets and changing the name. It's a good way to keep, if you have carefully set preconditions in here, like where the file's going, or we don't mess with the clip features because it's all the same. It's an easy way to keep, again, the preconditions set the same. Let's go ahead and run that. All right, and we can turn off chemical spill, and now we're getting down. And the final thing we would switch in, for example, would be where's rivers, and say spill clip rivers. And with this, we would have all the data sets present, cut down to our quote-unquote study area, and we turn rivers off. There we go. Everything is cut down. Again, this is just an example, so I'm just going to remove the clips that we don't need. Grassland clip, don't need that. We turn grassland back on and chemical spill back on, and all points. All right, and rivers. Okay, so we're back to where we were. So here is our original tool. The original thing we run was grassland clip. All right, what I want to show you is, so we open the attribute table. All right, and what do we have? We have polygon, shape, area. Okay, and that's it. That's all we see here. All right, as a comparison, let me scroll this down a little. So we use number one, our big buffer. Let me move that up. And what does that have in it? All right, it's got all this information. All right, and what we're going to do now is run the intersect tool. All right, and the reason I have both of these open is you'll see our buffer, this blue area here, and we'll run it on our grassland file. And one of the major differences between clip and intersect is how the output file's attribute table is constructed. All right, so let's hop back to geoprocessing, and under toolboxes again, analysis, overlay, intersect. And we want to intersect big buffer, okay, and grassland. Let me turn off the clip just to be on the safe side now. You'll see a couple of other bits of tools here. Ranking involves the priority in geoprocessing. So like coordinate systems, which coordinate system is going to be the highest ranking one if you have intermingling coordinate systems. Generally speaking, you don't necessarily need to mess around. All right, if no rank is given for the tool, all right, usually they're given all equal ranks. All right, so we're intersecting these two. If we were to add, I just want to show you, I'm not going to do it, rivers, you can continue to add files. Okay, let's say chemical spill, and it can keep going. All right, we don't want this many. We're just doing this for an example, and I'll show you the pitfalls of intersecting too many files in a second. So actually we want big buffer and grassland. So what intersect does, I'm sorry if I didn't say that, is it's similar exactly to clip. All right, geometric intersection of the input features. All right, we overlap feature classes written to the output features. Essentially the same idea. What I want to point out is the attributes to join option here. All right, so we have attributes, all attributes. All right, all attributes except feature IDs. It doesn't matter a whole heck of a lot. We want to generally keep all attributes. All right, so the output file is going to be a combination of the data set attribute table for grassland, which we have. If you turn this off and open grassland, that's the one we want. This data set, all right, which doesn't have anything in it, and the buffer set. All right, it's going to combine the two. With the clip, it was just a cookie cutter with grassland, so we could say grassland attribute table. All right, grassland attribute table and grassland. All right, it just has the minor addition of shape area and shape length as default additions to the output file that we ran with the clip feature. Okay, anyway, let's run the intersect. So we're intersecting buffer and grassland, this area, and let's just go ahead and make sure again we move it to your S drive. And so what we see is, let's turn buffer and grassland off. We're seeing the area of commonality, all right, between the grassland. It's a little different now, right? And the big buffer. So that's our buffer, right? And this is our chemical spill, all right? And what do we have that's common? That is what big buffer intersect shows. All right, the other thing to remember, as I was saying, is we have the two intersect features that we use as big buffer and grassland. All right, and big buffer intersect now will show a combination, a combined attribute table. So essentially the question is, for clip, it's a more simple tool. I just want the data set to be cut down. All right, with intersect, the output file will contain, if you're setting the attribute section up, it can contain potentially all the data from both of the features that are being combined. Now, when I say both, I'm saying it's a simple intersect. All right, what we could do additionally is, let me turn off this intersect and turn on grassland and chemical spill, get us back to where we were. Let us try, we could say big buffer, grassland, all right, rivers, and points. All right, what you're asking the computer is, where do all of these intersect? All right, let me change this out name-wise to overwrite. The caution here is, what you probably think is going to happen, all right, is you're going to get a cookie cutter. All right, but let's see exactly what does happen. All right, big buffer intersect 2. Where is it? The problem with it is there's no commonality. All right, you're asking the computer, return the area where all 4 buffer, grassland, river, and points are common. All right, the major limiting factor here is points. Points do not co-locate with any of the other files specifically. All right, so for this to happen, we would need literally a point to drop directly on one of these lines, and it would just return the area underneath, which is also nonsensical because I need to get to that in a second. Technically, it actually wouldn't return that part at all. But that actually brings me to my next point here. Let's drop all points and try it again. So what you're asking the computer is, what is common to buffer, grassland, and rivers? All right, and your output here, big buffer intersect, will be a line feature, or because the lines are the only things that satisfy the question of what file type satisfies crossing big buffer, crossing rivers, and crossing grassland. And it's this brown. Let's see if we can change that to red or something so you can see it. This red area is the only thing that's common. All right, let's go back. Other things. One of the things with intersect and generally just with intersect, if you have a polygon, okay, and you're trying to intersect it with rivers or points, the polygon is what we would call a two-dimensional object. It has height and width, so like we can calculate area. One-dimensional objects such as rivers, you can calculate length. And points, we can't calculate any type of dimension, it's just a location, so we can calculate latitude and longitude. The reason I bring this up is there's no actual geometric area beneath this point here, beneath any of these points. All right, so if we were to say return for me from buffer the points that intersect or that drill a hole through the buffer with those points. Okay, it can't do it because there's no hole there. There's no geometric area for the computer to remove or identify. Okay, so similarly with this, if you were to say return from me the buffer section that intersects the rivers, there's nothing there. All right, because these lines definitionally geometric don't have any width. All right, so what I'm getting at in the long term for this explanation is if you are intersecting at any point a polygon with a lower dimensional object like rivers, which are one dimension, and points, which would be 0 dimension, all right, you're always going to drop it down 1 dimension. So 2-dimensional objects intersected with 1 dimension, you'll always receive this 1-dimensional object back. All right, because the reverse of that is nonsensical. Okay, so that covers clip and intersect. One thing I wanted to say before we go is please check out where we talk about the differences between clip and intersect, all right, and select by attributes and select by location. The reason I bring this up is on occasion people have gotten confused because the definitions of these tools are slightly different, all right, than the definitions, for clip and intersect. Essentially, we'll talk about this in the select video. With clip and intersect, we're actually creating new data. We're cutting stuff and creating new shapefiles. With the select functions, we're just saying, hey, computer, please tell us what are the spatial objects that satisfy the query that we'll build. Okay, but that's it for clip and intersect.